Hi, welcome back to Mrs. Ogram's Maths. We are taking a look at some practice questions on the differentiation paper. This video is just going to focus on the achieved questions, so just the questions that would get you a U mark on the papers. Now, the way that these are set up on the papers in their current structure is these will always be parts A and B of each of the three questions on your external paper. I always recommend to my students that they start by doing part A and B of question 1, 2, and 3, and then go back and do part C onwards. So you know for sure you've got that achieved in the bag before you carry on to the merit and excellence questions. Okay, so for question 1, part A here, we have a product rule. We've got two pieces being multiplied together, so I'm going to write those out separately and use exponent form. So if we differentiate x to the half, we get half x to the minus half. And if you differentiate cot, that's on your formula sheet, cot becomes minus cosec squared x. So then differentiating y will be to use the product rule on them. So we do that cross multiplying thing where we cross over this way and this way and then add them together. So our final answer looks like this. And there is no need to simplify your answer on that. You can leave it exactly as it is. And when you've practiced these, you can probably skip doing this bit at the beginning that I did as well. You don't have to write out all of that. You can just give the answers when it's an achieved mark. But if you're still practicing these, I'd definitely write out these bits to begin with. Okay, so for part B, we want to find the gradient of the tangent to the curve given by this equation at the point when x equals 0. So first of all, we need an equation to get the gradient of the tangent, which means we just differentiate. And we have a quotient rule happening here. So again, separate out into our u and v parts. If we differentiate e to the x, we just get e to the x. If we differentiate x squared minus 1, we get 2x. So dy by dx is then going to be v du by dx, so ex x squared minus 1 minus u dv by dx all over v squared. Work out what that gradient is when x equals 0. So when x equals 0, we put 0 into every x term in our dy by dx, and we will get the answer that dy by dx is equal to minus 1. All right, now continuing on to question 2, so that we are just looking at those questions that are worth achieved marks. Now we've got a polynomial to differentiate for part A, and we can rewrite the cubed root of x as x to the power of a third. So dy by dx, we differentiate each term individually, so that'd be a third x, and then 1/3 minus 1 is minus 2/3. And on your formula sheet, you can check that sine x differentiates to cos x. So that sine becomes cos, 3x stays as it is, but we multiply by 3 when we're doing that trig. It's just a teeny little chain rule happening there. Okay, for part B, we've got the distance of a particle s. We want to know at what time the velocity of the particle, so at what time is the velocity 0? So to get from distance to velocity, you differentiate. That's kinematics from level 2. So the velocity of t is equal to the derivative of s. So that becomes 6e to the 2t minus 24e to the minus t. And the question asks us to work out what's the time when that equals 0. So let's set that equal to 0. So rearranging to solve this now, I've just taken this minus 24 over to the right side and changed e to the minus t into being over e to the t. And then we get that we'll have e to the 3t, if we bring that e to the t up here, is equal to 24 over 6, which equals 4. Then if we take log of both sides, we get that 3t equals natural log of 4, because the natural log is what undoes the e part, and so t is equal to 1/3 times the natural log of 4, which you could also give as a decimal answer. You could put this into your graphics calculator and use equation solver at this point to work out what t would need to be. All right, question 3, part A, brings us another product rule. So we've got x squared multiplied by natural log of 2x minus 1, which leads us to 2x and 2 over 2x minus 1. Putting them together in the product rule, we are going to do u times v dash, so that's 2x squared over 2x minus 1 plus v times u dash. So ln 2x minus 1 times by 2x. And again, there's no need to simplify. Okay, part B, find the gradient of the tangent to the curve at this point. So we need the gradient function first. So y is equal to 2x minus 2 to the power of a half. So dy by dx is half 2x minus 2 to the minus a half multiplied by 2 using the chain rule. So if we tidy that up, the 2 and the half cancel. So we just end up with this bit here. Okay, so the gradient of the tangent at this point, so when x is equal to 3, we will get the gradient being 2 times 3 minus 2 to the power of minus a half, which you can pop straight into your calculator and get the answer of a half. 2 times 3 is 6, minus the 2 is 4, square root it is 2, and then 1 over gives you a half. And that finishes us up for achieved questions on this paper. I will hopefully add more to this repertoire and playlist of achieved practice in the future, so just keep an eye on the channel if you found this helpful. I'm now next going to make one looking at the merit questions from this paper and put them into a separate playlist too.